We are going to do 1.2 with a little of 1.1 mixed in. We're going to talk about evaluating functions and composition of functions and function notation, kind of. So I can evaluate a function at a given point, and I can evaluate at an arbitrary point. I don't know how else to say this, but it's going to be like an arbitrary point, like I'm going to ask you to find f of the letter m. So I don't know where m is, but I'm going to ask you to find it, and I will explain that. So I'm going to give you two functions, f of x and g of x. And then, for example, I'm going to ask you to evaluate f of -2. So this is evaluating at a point. So what this means is plug in -2. So I'm going to write that down. So any place you see an x, we're going to plug in -2. So these are pretty easy, right? -2 plus 1. F of -2 is -1. Same for g. The only difference is when you have an x squared, you need to kind of make sure you give it parentheses, because you could get a different answer if you didn't do that. So I have -2, and I'm going to square it and subtract 1. If you're using a calculator, you need to make sure that you plug in those parentheses. If you type in -2 squared minus 1 in your calculator like this, you will get the wrong answer. If you do this, you will get the right answer, because -2 times -2 is +4. So g of -2 is 3. I'm going to ask you to do the same thing with letters. Okay, this is what I mean by like an arbitrary point. What's f of m? This means every place we see x, we're going to plug in the letter m. So m instead of x plus 1. That's your answer. Same over here. And it would be good practice to put your parentheses around it. When you add something to it, like m plus 1, we have to go a little further. So this means I'm going to plug in m plus 1 every time I see the letter x. So for f, I have m plus 1 plus 1. Since there's nothing here with my order of operations, my final answer is just going to be m plus 2. Okay, things get a little bit fishy, if you will, when we get to the squared. So I'm going to plug in m plus 1 every place I see x. So m plus 1 squared minus 1. Now, you need to FOIL. Okay, maybe I'll find some space over here. I'm going to erase some of this. Get a bigger eraser. Okay, hopefully you wrote this all down already, but I just need space to FOIL. Come on. The eraser tool has improved, but not fast enough yet for me. All right, so FOIL m plus 1. Oh, but now it doesn't write over what I erased. Learning all sorts of new things here. Let's find out. M. I guess my stylus just stopped working altogether. I'm going to hit pause here. Okay, so we're foiling m plus 1. It's like my stylus just quits working. Times m plus 1. So m squared plus m plus m plus 1. So this is what you should get. This is what gets kind of right here. Okay, so when you square a binomial, you have to FOIL. So if I go back to pink now, I really have m squared plus 2m plus 1 minus 1. And these two subtract, so you get this. Your homework is going to be page 11, numbers 41 through 46. This is where you stop for day 1. day 1. Okay, the next slide will be for day 2. To start, we have the same I cans, except for this time we're going to be able to compose functions. So I'm going to write that. I can compose. Not music, but functions. Okay? I know you can't see the S, but I promise it's there. So as a review from the first slide, when I give you a number, you just are going to plug it in. So this is going to be 1 plus 1 equals 2. Same thing down here. I'm going to plug it in. So I have 5 squared minus 1. So you get 25 minus 1, 24. Just like yesterday when I gave you a letter and I said, for example, if I say m plus 1, you plug in m plus 1. This time what I'm going to plug into f is this whole thing. So every time I see an x, I'm going to write x plus 1. So f of x squared minus 1 is, this is where x would go, right? So instead of x, I'm going to write x squared minus 1. Now it looks like this, and I can kind of combine these. X squared is my answer. What you just did is composition of functions. Okay? You took the whole function g, look at here it is up here, and you plugged it in every time you saw an x. So it looks like this. This is how we write composition of functions. Another one, it looks like this. You guys always think this is funny. It means g composed of f, but it really means, like that open dot means composed. And it means this. For every place you see g, you're going to plug in the whole function. I'm sorry, for every place you see x, you plug in the whole function f of x. Okay, so this right here means plug in, right? So I rewrote it. Instead of f of x. That looks super confusing. I'm going to plug in x plus 1. So now when I do my g of x, I'm going to plug in x plus 1. Oh, there it goes again. X plus 1, and then square it, and then subtract 1. And just like yesterday when we talked about this, you have to FOIL this. So you're going to have x plus 1 times x plus 1. FOIL. So you should get x squared plus 2x plus 1. That's what goes here. And then this minus 1 still gets carried down. And your final answer then is x squared plus 2x. And that's it. Okay, so kind of in review. Composition of functions is when you plug in the other function. So if you see something like this, f-o-g, it looks like fog. That's the same as f of g of x, which means f plug g of x in every time I see x. And if I was going to do it the other way, g o f looks like goth. That means g of f of x, which means I'm going to take the function g and plug in f of x every time I see x. Okay, that's what that means. These are tricky. They take practice. We will continue practicing on Monday. So page 17, you're going to do 6, 7, 15 through 20.